Hello. 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 Good evening. This is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South. We're broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band. Just a sec. Just turning down the volume on a couple of things there. Minimise background interference factors, and we're broadcasting on 3541 in the 80 metre amateur radio band, broadcasting by the Melbourne television repeater VK3 RTV digital channel number 1, which can be viewed on 445.5 megahertz using DVB-T2 set-top box, and or the BATC website, which I think is working. Let me just check that, and we'll just take up our mouse and click there. Oh, yep, we're on the BATC website video server. So if you can't view the Melbourne TV repeater, you can certainly see the direct output on the British Amateur Television Club video server website, which it is there. That's a bit of a distraction, so I shall go to my inbox. If you wish to send an email tonight, the address for the station here is vk3ekh@gmail.com, vk3ekh@gmail.com, and we're looking at the inbox as we speak. We also have a Discord chat window running, so if you install Discord and look for astronomy chat room, it's something Richard set up. Actually, originally it was Mr. Arrowsmith, but anyway, there's a few people there. So very pleasant good evening to Martin, Steve and Kim, VK5FUSE, who are already there on the chat window. Very pleasant good morning to you. Feels like the morning. And we're also on my YouTube channel, VK3CSJ, so if you wish to view tonight's proceedings 20 seconds behind what you're hearing on ATV and on the 80 metre band, by all means look at the YouTube channel. Once again, there's lots of pictures, so it's always good to be able to view the visual side of the cast. Anyway, providing my internet holds up, we should be right. Okay, on this 14th of July 2023, pleasant good evening to everybody, and I trust everybody is keeping warm. I don't know whether it's because I'm getting old or what, but it is definitely the chill factors is what's been occurring over the last few weeks, and I've been definitely feeling it to the bone. So tonight's no different. The old air conditioner's working flat chat, but it's not making much of a difference, so I would love an open fireplace. It would be really nice. Alright, the Astronomical Society of Victoria, of which this broadcast is on behalf of, and has been running since 1988, was founded in 1922 and comprises well over 1,600 members scattered about the world, mostly Australia, Victoria. And membership of the society, of course, is open to anybody with an interest in astronomy. The society's objectives are to study and practice of astronomy, and to disseminate the knowledge of the science, and to provide facilities for members to continue on their study. Monthly meetings are held every second Wednesday of the month at the Mullier Hall in Burwood Avenue, the National Herbarium, not too far from the Shrine of Remembrance. Plenty of parking in in Burwood Avenue there. Admission is free, and visitors are most welcome indeed. Meetings kick off at 8 o'clock on the noggin, and the aim is to finish right on 10 o'clock with a free tea and coffee afterwards with some biscuits. I'm on a bit of a keto diet at the moment, which means no sugar, no biscuits, no Tim Tams, no sugar in the coffee. So it's been a few weeks of that. I've lost weight though. I've gone down from 99 point something kilograms. I'm currently hovering around 93, so it must be working. Anyway, privileges of membership include the right to borrow books and periodicals from the extensive library located at the Melbourne Observatory. And that includes the ASV's magazine called Crux and the annual publication, which is called the Astronomical Yearbook. That's it. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory, and monthly meetings weather permitting. These instruments include the Society's 300mm equatorial reflector, and there's also a 300mm portable reflector. There's also a 200mm refractor, which is managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory and are accessible too. The Society also has a number of 200mm reflectors available for short period loan for members wishing to get the handle on a telescope, and if they've got sons and daughters who've got a bit of interest in astronomy, to get them to get a feel for a telescope and to see what they can actually see through a scope. So that's telescope loan that ASV offers to members. Members are also encouraged to make use of the Society's country property located just north of Heathcote, not too far from Ladies Paris. And there's a range of instruments located there. There's a 300mm to 1000mm telescope, and which members can use with appropriate training. Also located on the site is a fully steerable 8.5 metre radio telescope, a Kennedy dish, similar, was actually the same as what Doug MacArthur, the late Doug MacArthur has, or had, still has up there at the property at Redburn. I can't remember now where it was. And of course, members can also access the radio astronomy setup through involvement with the radio astronomy section. Good evening to any of the radio astronomers members that might be viewing tonight. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do similar things. Instrument making is just one of the common interest activities catered for within the Society. There's now 22 sections. Let me just check the sections tab. Yes. No, just stay there. In no particular order, but alphabetical mostly. There's the astrophotography section, the club section, comet and meteor section, computing section, cosmology and astrophysics, deep sky, historical section, instrument making, juniors for the young lads and girls, lunar and planetary, new astronomers group, radio astronomy, solar astronomy, space exploration, and a new section that's been around now for a few months called Women in the ASV. So all information on those sections can be gleaned from the website at www.asv.org.au. when you click on those sections, a separate page opens up which gives you information about what goes on with each section. And if you feel like participating or rolling along on a Zoom meeting, or perhaps rolling along to the actual meetings themselves, which I believe at the moment the actual new club room located at the Melbourne Observatory now, the Ellery Suite it's called, is out of bounds at the moment. I'm not really sure why, but there's apparently some renovating going on, and that room is not accessible at the moment. So almost weekly there are meetings going on, and I think at this stage most are being done via Zoom. So again, that information is available from the section directors, and which can be found at those individual sections. So you don't have to be a member to contact a section director and ask if you can just sit on a meeting as a visitor. It's quite fine, but always go through the section director is what I'm saying. And then you can become a member. And of course, becoming a member of the ASV is all easy peasy, at least I think it is. The website's still going through a few changes. I think they've got the ability to become a member all sorted out, so that should be possible. Anyway, so there it is. If you wish to write a letter, the old traditional method of contacting, you can address your letter to the Secretary of the Astronomical Society of Victoria at GPO Box 1059, 1 minute to 11. GPO Box 1059, Melbourne, Victoria 3001. And of course the ASV will conform to any government directives if we need to close or postpone events. That's what we have to do. So that's a very, very quick rundown of the ASV, like I do every Friday. I always run through that little bit of blurb, and that time it was very much an ad-libbing one rather than staring at my notes. Just feeling a little bit relaxed at the moment, which is cool. I like that. One of my favourite announcers was Clive Robinson. I really liked him, especially when you did the TV side of it. So there it is. All right. Now, let me just have a quick look, revision of Sky Notes for July, for those that weren't around last week or the week before or the week before that. We have. He's further back up the page. Mercury. Mercury is not visible early in the month, being too close to the Sun, after having moved behind the Sun through its superior conjunction. But by the end of July, it will be visible again, but at dusk, low in the northwest from 6 p.m. after setting by 7:30 p.m. So, I say this all the time. If you haven't actually seen Mercury by eye from the back door of your house yet, there's a chance at the end of July to see Mercury just after sunset. It'll be far enough above the horizon to be able to see before 8 p.m. Before setting at 7:30. That's Mercury. Venus continues to be, and some folks have already pointed this out, and I know I've mentioned this already, but there's at least a couple of people that may be listening tonight that have pointed out this star in the afternoon sky. Well, it's Venus. It's not a star, it's a planet. Venus continues as the evening star, even though it's what it says here, colloquially, it doesn't matter, in the northwest, visible from 5:30 p.m. and setting by 8 p.m. It has just passed its greatest elongation east, and its furthest angular separation from the Sun as seen from Earth. So yes, Venus is that bright object in the morning, and there was a beautiful arrangement this morning. There was almost a new moon, not quite, but there was almost a new moon this morning, with Venus not too far from, in that twilight colour of the sky. I had to, before getting in, I was already late for work, but I had to, I'm late for work every day. But before I got in the car, I stood there at attention looking up at that magnificent combination of the moon and Venus. Really nice. I'm going to go straight to Mars. Mars is visible from, that's FORM. Mars is visible from 6 p.m. in the northwest at dusk before setting by 8:30. The red planet is not a bright object, as its distance is currently 326 million kilometers, and when it is at its closest approach to Earth, it can be about 55 million kilometers. Jupiter is an early object seen from 2 a.m. in the northeast before fading view from the early dawn light. And Saturn can be seen as a pale and yellow dot in the sky from 10 p.m. in the east and across the north during the night before lost in the west by 7 a.m. So that's the planets in a nutshell. So yes, it's Venus. No, I won't go worry about that. Okay, let's read out a few on this day dates to finish off this calendar of events. I don't think I've got all the way through that yet. And I think the last date I read out, last Friday, was, and I can't remember really. I'll go from here. What's the date? It's the 14th, isn't it? Yes, the 14th. I'll start off here. On the 16th of July 1969, Apollo 11 launches to the moon for the first lunar landing 5 days later. Also on the 16th of July 1994, oh yes, this was a wonderful time. Wasn't this an absolutely amazing time for everybody interested in astronomy? On the 16th of July 1994, Jupiter is struck by over 20 fragments of comet Shoemaker-Levy 9, with Earth-based telescopes and the Hubble Space Telescope observing the unique event. Well, it wasn't just so much the Earth-based and Hubble, there was a lot of other people doing observations too. And it was suggested, I can't remember who suggested it, but anyway, somebody said, why not tune in to 21 megahertz and see if we can detect any interesting interference or emission from the explosive nature of the fragments entering the upper atmosphere of Jupiter. And from first-hand experience, I was already involved with the radio astronomy section of the ASV at the time. I became a member, I think, in 1993. And because we were all aware of this Comet Shoemaker-Levy thing, we decided to set up receivers. Our little meeting group set up 3 receivers. 3? Well, there were 3 receivers set up anyway. And NASA had provided potential prediction times for when these impacts were going to occur. So these were the days of chart recorders, machines that used to rip through heaps of paper very quickly. But chart recorders, to me, radio astronomy is an antenna, a receiver and a chart recorder. That's the basic arrangement. And boy, did I have fun sitting there in my subdued lit room with everything else in the whole house turned off to minimize interference. but I had my sheet of potential predicted times, and I'm sitting there with a chart recorder going crazy with a WWV time signal transmission running for accuracy. Anyway, we did this, and the end result was we got our charts together on the old clubroom table, which I miss, and it was amazing to compare our charts and the time fragments and the time associated with the fragments, and we believe we correlated some of those fragments. Doug MacArthur, with his 8.5 metre dish, got wind of it at the last moment, and he decided to point his dish towards the moon. Of course, his dish only had 400 megahertz receiver on it. It might have had 23 centimetres on it. Centimetres, not sems. And he actually detected some emissions at 400 megs as well. So that was really interesting. It was an amazing time, and Monash University was up there at Mount Burnett. They had their set up. They built a dipole antenna across the reservoir that sits up there near the observatory, and they managed to develop a baseline a few weeks before the fragments occurred, and then of course they recorded not only solar flares leading up to this event, but they also recorded, from what I understand, fairly faithfully, the fragments. Some of the fragments. Unfortunately, there was an accident with the data, and a lot of it was lost. So that was a bit of an unfortunate thing about that episode. But it was an exciting time. 16th of July. 1994. 20th of July, however, on 1969, the year 1969, Apollo 11 landed on the moon. It touched down at the Sea of Tranquility. It's amazing the amount of people that don't think we went there. The 21st of July 1969, first human set foot on another world. Oh, this is just a continuation of the Apollo event. It's kind of dating it. On the 22nd of July 1784, the first use of parallax, and hence the calculation of the distance to a star, was done by Frederick Bessel. That was 1784. The 23rd of July 1995, Alan Hale and Thomas Bob discover a comet now named after them, Hale-Bopp. Also on the 23rd of July 1928, Vera Rubin was born, famous for analysing the rotation of rates of galaxies. On the 24th of July 1969, first lunar landing mission, Apollo 11, ends with command module splashdown in the Pacific Ocean. On the 30th of July 1971, the first lunar rover used on the moon, Apollo 15 mission. That was 1971. And the last date here, on the 29th of July 2005, dwarf planets Eris and Makemake are announced, leading to Pluto becoming a dwarf planet as well. Those sky notes were courtesy of Tanya Hill, the resident astronomer at the planetarium. Thank you, Tanya. So we're hanging out now for August's sky notes. You are tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Stephen has sent me an email, and he says, I'm pounding in here to the Borderlands at 30 over 9. He's watching via the BATC live stream. Picture is perfect and sound is perfect. Thank you, Steve-O, Mr. HK. You didn't send it to the right address, though. Anyway. I haven't checked my own email, the inbox, which I always request. We have emails from Stephen, VK3SPX, from Greg, VK3 Delta X-Ray, Mr. VCL, Graham Lewis, and Stephen. Again. Was it the other Stephen? Oh, you did. Why did you send it to my other email then? You already sent it to the proper email. Yeah, I know you're not a well lad, but I don't know. Alrighty. First article for tonight at 26 minutes past the hour. You would have thought that the James Webb Space Telescope was pretty good. Well, they're doing something a little bit better, it seems. We're about to. A new thin-lensed telescope design could far surpass the James Webb Space Telescope. Goodbye to mirrors, hello diffractive lenses. Courtesy of astronomy.com. Astronomers have discovered more than 5,000 planets outside of the solar system to date. The grand question is whether any of these planets are home to life. To find the answer, astronomers are likely need more powerful telescopes than exist today. The author says, I am an astronomer who studies astrobiology and planets around distant stars. For the last 7 years, I have been co-leading a team that is developing a new kind of space telescope that could collect 100 times more light than the James Webb Space Telescope, the biggest space telescope ever built. Almost all space telescopes, including the Hubble and Webb, collect light using mirrors. Our proposed telescope, the Nautilus Space Observatory, would replace large, heavy mirrors with a novel, thin lens that is much lighter, cheaper, and easier to produce than mirrored telescopes. Because of these differences, it would be possible to launch many individual units into orbit and create a powerful network of telescopes. Now, there's a little picture of this, artist's impression, I guess you'd call it. There it is. That picture is subtitled saying, a light, cheap space telescope design would make it possible to put many individual units into space at once. That's what you're kind of seeing there. So the need for larger telescopes are exoplanets, planets that orbit stars other than the Sun, are prime targets. In search of life, astronomers need to use giant space telescopes that collect huge amounts of light to study these faint and faraway objects. Existing telescopes can detect exoplanets as small as Earth. However, it takes a lot more sensitivity to begin to learn about the chemical composition of these planets. Even Webb is just barely powerful enough to search certain exoplanets for clues of life, namely gases in the atmosphere. The James Webb Space Telescope cost more than $8 billion US and took over 20 years to build. The next flagship telescope is not expected to fly before 2045 and is estimated to cost $11 billion. These ambitious telescopes projects are always expensive, laborious, and produce a single powerful but very specialized observatory. A little bit more on the lenses involved. There is a little picture here of somebody holding a lens. There it is. In 2016, aerospace giant Northrop Grumman invited me, the author, and 14 other professors, I'm tired, and NASA scientists, all experts on exoplanets and the search for extraterrestrial life, to Los Angeles to answer one question. What will exoplanet space telescopes look like in 50 years? In our discussions, we realised that a major bottleneck preventing the construction of more powerful telescopes is the challenge of making larger mirrors and getting them into orbit. To bypass this bottleneck, a few of us came up with the idea of revisiting an old technology called diffractive lenses. Conventional lenses use refraction to focus light. Refraction is when light changes direction as it passes from one medium to another. It is the reason light bends when it enters water. In contrast, diffraction is when light bends around corners and obstacles. A cleverly arranged pattern of steps and angles on a glass surface can form a diffractive lens. The first such lenses were invented by the French scientist Austin John Frenzel. Oh, we finally got through that. In 1819 to provide lightweight lenses for lighthouses. Today, similar diffractive lenses can be found in many small-sized consumer optics, from camera lenses to virtual reality headsets. And I've got another image here to show of this. There. All right. So that a diffractive lens bends light using etchings and patterns on its surface. This new lens design makes it possible to rethink how a space telescope might be built. In 2019, our team published a concept called the Nautilus Space Observatory. Using the new technology, our team thinks it is possible to build a 29.5 foot, 8.5 meter diameter lens that would be only about 0.2 inches, 0.5 centimeters thick. The lens and support structure for our new telescope would weigh around 500 kilograms, and this is more than 3 times lighter than a Webb-style mirror of similar size, and would be bigger than Webb's 21 foot, 6.5 meter mirror diameter. The lenses have other benefits too. First, they are much easier and quicker to fabricate than mirrors, and can be made in massy. I guess that's French. Second, lens-based telescopes work well even when not aligned perfectly, making these telescopes easier to assemble and fly into space than mirror-based telescopes, which require extremely precise alignment. Finally, since a single Nautilus unit would be light and relatively cheap to produce, it would be possible to put dozens of them into orbit. Our current design is in fact not a single telescope, but a constellation of 35 individual telescope units. Each individual telescope would be an independent, highly sensitive observatory able to collect more light than Webb. But the real power of the Nautilus Observatory would come from turning all the individual telescopes toward a single target. By combining the data from all these units, Nautilus light collecting power would be equal a telescope nearly 10 times larger than the Webb. With this powerful telescope, astronomers could search hundreds of exoplanets for atmospheric gases that may indicate extraterrestrial life. Although the Nautilus Space Observatory is still a long way from launch, our team has made a lot of progress. We have shown that all aspects of the technology work in small-scale prototypes, and are now focusing, pardon the pun, on building a 1 meter diameter lens. Our next steps are to send a small version of the telescope to the edge of space on a high-altitude balloon. With that, we will be ready to propose a revolutionary new space telescope to NASA and hopefully be on the way to exploring hundreds of worlds for signatures of life. Well, let's hope that does come to fruition at some point in time. Probably won't be around for that. Okay, it's 10:35. You're tuned to ASV Radio, VK3EKH. G'day to David, VK3KDM, who's just joined. Now, our next interesting article tonight. The Hubble telescope captures the making of a cosmic monster. And we have a picture of the general field that he was looking at. Let me see, but it's a quick article, this, I think. The massive cluster of galaxies, we're looking at on the screen right now. The massive cluster of galaxies lies about 8 billion light years from Earth. A cosmic monster is growing in a distant corner of the universe, and we just got a look at it. The Hubble Space Telescope captured a stunning new view of massive galaxy cluster called EMACS J1353.7 plus 4329. This cluster lies about 8 billion light years from Earth in the constellation of Canes Venati C. So, for perspective, the farthest object ever observed lies 13.5 billion light years from Earth. This galaxy cluster is a monster in the making, they reckon, consisting of at least 2 elliptical galaxy clusters in the process of merging together, according to statement from the European Space Agency. The cluster of galaxies is visible in the new Hubble image as a dense crowd of oval shapes. Each galaxy has a glowing orange halo around a bright core. Numerous other galaxies are sprinkled throughout the image that you're seeing on the screen at the moment, along with a bright star that exhibits a starburst effect with 4 distinct diffraction spikes. Yes, we can see that. This cosmic monster of galaxy clusters acts as a gravitational lens, allowing researchers to study early galaxies in greater detail than they otherwise could. Gravitational lensing occurs when massive foreground objects such as the emerging galaxies warp the fabric of space-time, such as the light from more distant objects is magnified or distorted. A celestial body, such as a galaxy cluster, is sufficiently massive to distort space-time, which causes the path of light around the object to be visibly bent, as if by a vast lens. ESA officials said in a statement, "The first hints of gravitational lensing are already visible in this image as bright arcs which mingle with the throng of galaxies in EMACS J1353, which you can see. In the image, the effects of gravitational lensing can be seen to the right of the largest central galaxy, which has stretched a background galaxy, causing it to appear as 2 connected thin arcs. The recent observations of EMACS J1353.7 plus 4329 were taken at multiple wavelengths using Hubble's Wide Field Camera 3 and Advanced Camera for surveys. The data was collected as part of an initiative called Monsters in the Making, which targets 5 exceptional galaxy clusters. The Hubble's observations of these vast gravitational lenses lay the groundwork for studying such objects in even greater detail with NASA's James Webb Space Telescope. So there it is. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, coming to you from the studios of Mary Warren South. VK3 CSJ on the microphone. Cheers. India's up to its tricks again. they really do want to get to the moon. India has launched a historic Chandrayaan-3 moon rover to land at the lunar South Pole. India hopes that Chandrayaan-3 makes it the fourth nation to land on the moon. And we do have a picture of the rocket taking off, although it's a still image. Some of these websites have video, which I just, if they're not YouTube, they're a real hassle to download. I don't know the tricks to that. My YouTube downloader works fine, but for other videos that are embedded in other websites like space.com and the like, a bit tricky to download. Anyway, there it is. That's the Chandrayaan-3. A launch vehicle called Mark III, that is to say, LVM-3 rocket topped with the Chandrayaan-3 spacecraft lifted off from the Satish Dhawan Space Centre on the coastal island of Sriharikota on the 14th of July, and the rocket thundered into space carrying an uncrewed lander rover Lander Rover Duo, and the hopes of the world's most populous nation. About 16 minutes after liftoff, Chandrayaan-3 separated from the LVM-3 as planned and entered into orbit around Earth, kickstarting its fuel-efficient journey to the moon. If the rest of the mission unfolds as planned, India will soon become the fourth country after the United States and the former Soviet Union and China to land on the moon. The ambitious homegrown mission was relatively modest price tag of 6 billion rupees, or $73 million US. Its success would accelerate India's growing ambitions of low-cost space exploration during a time when many nations are establishing a long-term presence on the moon. Today's launch commenced India's second shot as gently landing on the moon's surface, a venture that comes nearly 4 years after Chandrayaan-2's lander rover pair crashed into the moon due to a software glitch. Officials at the Indian Space Research Organisation, the country's national space agency, say they're pretty confident this time of a success of landing, so stay tuned. There's plenty more to that article, but I shan't read it. That's courtesy of space.com if you wish to catch more to that story. Back to me, and next article. This is VK3 Echo Kilo Hotel. Okay, this is a bit of an advertisement for Astrophiz. G'day to Brian, Brendan, if you're listening. What do I call you Brian for? I keep doing that. Brendan. Oh yes. Okay, I've got a still image here. Okay, you see this chap on the screen right now? Well, his name's Greg Sleep. How does people end up with a name like that? At least I can pronounce it. Anyway, Greg Sleep, Astro Data Wizardry. Let me see. This is the latest podcast from Brendan O'Brien's Astrophiz website. It's Astrophiz, ASTROPHIZ, astrophiz.com. And what we see here is, in summary, in this fabulous episode of Astrophiz, Greg Sleep, the software and systems team leader at CIRA, the Curtin Institute of Radio Astronomy, which is a node of ICRAR, the International Centre of Radio Astronomy Research, discusses the Murchison Wide Field Array and its role in capturing radio data from the cosmos. And before I go on, I might add that the ACMA is about to designate a large swath of land around the Murchison Observatory over in Western Australia as a RF quiet zone. Similar concept to the Greenbank Observatory in America. So I'm not sure how they're going to be able to do that, but the ACMA is about to release an official statement, if they haven't already, of the area around this part in Western Australia to be considered an RF quiet zone. Continuing on with the summary, the MWA is a low-frequency radio telescope array located in the remote Western Australia. It is used for various scientific studies, including the search for signals of the epoch of the reionization, detecting black hole radio jets, transients, GRBs, FRBs, pulsars, SETI research, and studying supernova remnants, and monitoring space junk. The MWA has been successful in producing over 300 journal papers and is preparing for future developments, including the use of all 256 tiles and collaboration with the Square Kilometre Array Telescope Project. That's about it, really. So, yes, you can tune in to that recording, to that interview with Greg Sleep, Astrophiz episode 175, by going to astrophiz.com and pressing the button on listen to the sound file. And we shall catch up with that over the weekend, I suspect. I can hear something. Not sure what that is. It's a funny sound. Where am I hearing that? Hearing something, I'm not sure what that is. Anyway, it doesn't matter. As long as it's not going out over the broadcast, that's the main thing. Alrighty then, at 13 minutes to 11, this is VK3 Echo Kilo Hotel, and I haven't got my picture up yet. Where is my picture? My camera. Where is my camera? VMix, I tell you. Alright, now, next on the list of discussions. Yes, alright. Yes, this is a short article. Saturn's rings dazzle in new JWST portrait. The unique image is the Space Telescope's first near-infrared observation of the ringed planet. Saturn's rings are glowing in a new image taken by the James Webb Space Telescope. The effect is caused by methane gas in Saturn's atmosphere, which absorbs incoming sunlight and makes the planet appear dark. By contrast, Saturn's rings lack methane, so they are the standout feature at this wavelength. And here's the picture. Here is the picture. Here is the news. There we are. So what you're seeing is Saturn. Saturn's rings consist of pieces of ice and rock ranging in size from a grain of sand to earthly mountains. There are 7 main rings around the planet in order from closest to farthest: ring D, C, B, A, F, G, and E. Each ring was named in alphabetical order in the sequence they were discovered. At only a few 100 million years old, the rings are young compared to the age of the solar system and may have formed from Saturn's gravity tearing up one of its moons, tearing up one of its moons, or a passing comet or asteroid. Each ring orbits the planet at different speed. Other deeper exposures taken from the NIRCam allowed researchers to look at some of the planet's less vibrant rings not seen in this photo, including G and E rings. E-rings. The latter of which extends roughly between the orbits of Saturn, moons Mimas and Titan. I've got another image here with these names. So there they are, with the names attached. I'm just setting up my camera again here. So what other details are there? The photo also shows 3 of the planet's icy satellites, Dione, Enceladus, and Tethys. Out of 146 known moons, the 3 seen in the image appear as red points to the left of Saturn. Okay. This year, the James Webb Space Telescope also discovered a large plume of water vapour jetting from Enceladus that feeds the Saturn E-ring. The plume spans more than 9,700 kilometres. Currently, Saturn is experiencing summertime in its northern hemisphere. JWST captured Saturn's atmosphere in surprising detail at an infrared wavelength of 3.23 microns. This allowed astronomers to view Saturn in ways the Cassini spacecraft could not show. Despite its high resolution at other wavelengths, the planet's familiar stripes are not visible in the near-infrared image because of the methane in the upper atmosphere blocks the view of lower clouds. We are very pleased to see JWST produce this beautiful image, which is a confirmation that our deeper scientific data also turned out well, said Matthew Tiscanaro, a senior research scientist at the SETI Institute, in this press release. We look forward to digging into the deep exposures to see what discoveries may await. Yes, I can't wait to get my own telescope set up in the backyard so I can take pictures of this wonderful planet from here, from my backyard. Dear. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South. Okay, we're making a bit of a James Webb Space Telescope night, aren't we? But the thing here also is that the Space Telescope is now 1 year old. It's now just over 12 months since James Webb's telescope was launched and commissioned into its orbit. So NASA's new James Webb Space Telescope image, this new image, shows a chaotic scene of newborn stars. Now, this is one of these video images that are embedded in the website, and the only way I could get this to work was do a copy of the URL, which vMix accepts. So let me see if this is going to work for me. I'll just punch this across. Hang on. Not that one, that was the wrong image. Where are we with this image? There it is, this one. Okay, let's see if we can get this. It's a GIF image, well, it's animation. But anyway, let's see if this will play. Hang on a sec. Oh, there we go. All right. It starts with the constellation of Scorpio, and it zooms in and it zooms in and it continues to zoom in. And we're looking for a place called Rho Orpheus Chi. I think that's how you pronounce that. There it is. That coming up on the screen right now. And it's just going to stay there. Okay, that's good enough. I'll see if I can just rerun that. Okay, so it starts off Orpheus. You can see the Orpheus and the constellation Scorpio. And we zoom in to come in on what we call Rho Orpheus. I don't know how you pronounce that. But it's a cloud complex. It is the nearest star-forming region to Earth, NASA's statement explains. It is a relatively small, quiet stellar nursery, but you'd never know it from Webb's chaotic close-up that we see there. Oh, hang on. I'll go to the close-up image that I've got of it. There it is. It's a much more detailed image. Those red areas pictured above are jets of molecular hydrogen. So those reddy coloured regions in that image is molecular hydrogen. These occur when a star first bursts through its natal envelope of cosmic dust, shooting out a pair of opposing jets into space like newborn first stretching her arms out into the world, NASA says. There's about 50 young stars in the image, most of them being a similar mass to the Sun or smaller. The brightest white circle in the green yellow swirl of cosmic dust is a star called S1, which NASA says is significantly more massive than the Sun. Some of the stars have shadows that suggest the presence of what's called a protoplanetary disk, which sounds like a solid object, but is actually a massive ring of space dust and gas left over by the star's formation. As dust grains and gas swirl around a star, gravity clumps them together. These clumps become larger, forming planets and moons, and eventually a solar system grows around the star. Our own planetary system around the Sun was formed in this same way. So, in a way, this image is like an ultrasound of a baby, except the baby is a planetary system. Webb's image of Orpheus, I can only think of Orpheus, but it's not Orpheus. Rho Orpheus allows us to witness a very brief period in the stellar life cycle with new clarity. Our own Sun experienced a phase like this long ago, and now we have the technology to see the beginning of another star's story. So there it is. Rather startling imagery. It really is. I wouldn't be able to see that with my telescope, I don't think. Oh, blah, 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 blah. All right, what is the time? It's about 3 minutes to 11. Do I have time for one more article? Oh, yeah, okay. We might go over time. If you want to go to bed, you can. All right, this is interesting. The world's largest nuclear fusion rocket engine begins construction. 14th of July 2023, spacealert.com. Nuclear fusion propulsion technology has the potential to revolutionize space travel in terms of both speeds and fuel usage. The same kinds of reactions that power the Sun could halve travel times to Mars, or make a journey to Saturn and its moons take just 2 years rather than 8. It's incredibly exciting, but not everyone is convinced that this is going to work. The tech needs ultra-high temperatures and pressures to function. To help prove the viability of the technology, the largest ever fusion rocket engine is now being built by Pulsar Fusion in Beachley in the UK. The chamber, some 8 metres long, is scheduled to start firing in 2027, and here is a picture of it. There it is, coming up. 2027. As you might expect, replicating the Sun inside a rocket ain't easy. At the centre of nuclear fusion propulsion is an ultra-hot plasma locked inside an electromagnetic field, and scientists are continuing to figure out how to do this in a stable and safe way. The difficulty is learning how to hold and confine the super-hot plasma within an electromagnetic field, says James Lambert, CFO of Pulsar Fusion. The plasma behaves like a weather system in terms of being incredibly hard to predict using conventional techniques. Machine learning could help make the box of wild weather a little easy to map. Pulsar Fusion has partnered with Princeton Satellite Systems in the US to use supercomputing algorithms to better predict how the plasma is likely to behave and how it might be more precisely controlled. If scientists are able to get everything functioning as intended, temperatures of several 100 million degrees will be reached in the chamber, making it hotter than the Sun. The surplus energy released could potentially drive rocket speeds of up to 804,672 kilometers per hour. The particular type of engine we're talking about here is a direct fusion drive, or a DFD, in which the charged particles create thrust directly rather than converting into electricity. It's more efficient than other options, and as it's powered by atomic isotopes, doesn't need a huge fuel payload. You've got to ask yourself, can humanity do fusion? Pulsar Fusion CEO Richard Dinnan told TechCrunch, if we can't, then all of this is irrelevant, he says. If we can, and we can, he says, then fusion propulsion is totally inevitable. It's irresistible to the human evolution of space. Sounds good to me. As well as making round trips to the planets much shorter, nuclear fusion also promises to provide almost unlimited clean energy for life here on Earth. However, scientists think it'll be demonstrated in space first, where the lack of any atmosphere and the ultra-cold temperatures are more conducive to reactions. Well, I wish them luck on that. We have to seriously look at a way of doing things in space travel a little bit differently than just burning fuels. So yes, there it is. Alright, spaceweather.com. What's happening up in space? Let me get to my spaceweather.com. Oh, there's a beautiful image here. Look, I'm just going to show this. This is all part of space weather. Unfortunately, Tamitha doesn't have any solar reports at the moment, so I haven't got any reports from Tamitha. But here is a beautiful image. Let me see if I can run this, because this is again a video embedded in the web page, and I'll see if I can run this. April 2023. Alright. More information can be found on space.com if you wish to. Look for that article. Astronomy.com. Sorry, space.com. Oh, it stopped. Alright. Back to me. Now, spaceweather.com. The first image to bring up is our disk sun. There it is. Okay, this is the current disk of the sun, and we are sporting several sunspots. 1, 2, 3, 4, 5, 6, 7, 8. 8 sunspots on that. And the solar wind is currently at 360. The solar losing my voice now. The solar wind is current testing 1 2. Excuse me. Testing 1 2 3. Testing. The solar wind is it's time for a glass of water. Hang on. That's better. The solar wind is currently at 326.8 kilometers a second at a density of 4.12 protons per cubic centimeter. The current sunspot number is 146, while the radio sun is at 203 solar flux units. I just don't think I've ever seen it above 200. 203 solar flux units measured at a wavelength of 10.7 centimeters. Geomagnetic storm watch. NOAA forecasters saying that there is a minor G1 class geomagnetic storm possible today, July 14, when a CME is expected to hit Earth's magnetic field. The CME has hurled into space on July 11 by an erupting magnetic filament in the Sun's southern hemisphere. Most of the CME will sail south of our planet, glancing below from its northern flank, however, may be enough to cause minor storm, they reckon. And the K factor, where are we? The planetary K index, KP, at the moment the K index is equal to 3.67, which is considered quiet. The 24-hour max is the same, 3.67, considered quiet. They've got an article within spaceweather.com on the Bastille Day event. You know a solar flare is strong when even the Voyager spacecraft felt it. 23 years ago today, 14th of July 2000, the Sun exploded with so much force it sent shockwaves to the edge of the solar system. At about 11 a.m. in Western Europe, where Bastille Day celebrations were underway in France, Earth-orbiting satellites reported an X 5.7 class solar flare. Within the hour, energetic particles accelerated by the flare reached our planet. Protons and electrons hit the atmosphere and created a cascade of radiation that reached all the way down to the ground. People flying in commercial jets at high altitudes would have received double their usual radiation dose. And it's considered the strongest activity in the past 20 years. And I've got some SOHO images here. They're a GIF image, so you'll see the flare here on the image now. There it is. It's just in the center of the screen, and as it bursts, it sends all this radiation out towards the camera, and it hits the CCD lens, the charge couple device in the probe, and registers as particles of radiation hitting the CCD. There's another one here. This one shows the flare. There it is. And all of a sudden, the radiation is so intense that it overwhelms the camera looking at the sun, and it just is overwhelmed. All those particles hitting the CCD just light it up like a Christmas tree. Really quite stunning when the sun decides to its little thing. Despite all that, the cosmic radiation is still reducing due to the increase in solar flare activity. Cosmic radiation always is reduced as a result of that as we go into cycle 25. Also, the where I'm trying to pick up the auroral oval over the South Pole. That's the current auroral oval, which is not much to speak of at the moment. There's a slight hint of it there, but it's not causing anything to be seen in Tasmania or the mainland at the moment. So it's pretty average looking auroral oval over Antarctica. So that's about it. And I think the final thing to say about spaceweather.com is, as of the 14th of July 2023, there were 2,335 potentially hazardous asteroids. So thank you very much, everybody, for listening and tuning in tonight. To everybody who sent emails there, Stephen, Graham, Wayne, Greg and Stephen. Thanks, chaps. to everybody that came up on the chat window tonight. Martin, Steve, Kim, David, our MBO resident, and Martin VK7JAH. Oh, he's given me a pronunciation here. Orpheus. Yeah? Orpheus. 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 Orpheus? Orpheus. All right. Thanks, Martin. I'm horrible for tripping over big words, and particularly people's surnames if they don't make sense. Anyway, that's because I went to the Dandenong Technical School. I blame it square on them. All right. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. Tonight, concluding with tonight's broadcast, thank you very much for listening in, everybody, and we shall now take a quick call-in on 3541 to see if there's any stations wishing to check in. And let me just turn my page over on my logbook here so I can start a new page, and date it the 14th of July, and there it is. All right, now there won't be any audio patched through, so you're just going to have to listen hard through the microphone. It's too much of a hassle for me to get behind the radio right now to plug in the audio, so I've got to get that sorted out. Anyway, that's another thing here. This is VK3CSJ, listening on 3541. Okay, there were a few doubles there. VK3GL, VK3TJS, VK3JR,